Hello, and welcome to a little video about Target 3D, where we're going to be determining recursive and explicit expressions in contexts. Alright, first, let's just warm up ourselves with this arithmetic sequence, find out what the next term's going to be. Well, if it's arithmetic, what we're going to do is term 2, negative 13, whoops, I meant to make that a black marker, my bad, negative 13 minus negative 17. Well, negative 13 minus negative 17 is positive 4, so my pattern is to add 4. Negative 1 plus 4 is 3. Okay. Now, what I'd like us to do is to create a recursive formula. Technically, what you were doing with that subtracting is the recursive formula. Let's write it down. All right, this is the recursive formula, AN, which is any term equals an minus 1, previous term, plus d, plus common difference. All right, so an means any term, an minus 1 means the previous term, and d is the common difference. So we can get any term by taking the previous term and adding the common difference to it, which is how we found 3 in that pattern. We took negative 1 and we added 4 to it. All right. Let's write the formula. So the only thing we really need is d, the common difference. So let's find it. In order to find d, our common difference, we're going to do term 2 minus term 1. So negative 9 minus negative 2, which is negative 7. I don't know why I just said positive. That's crazy. Negative 7. See, that's why we got to use calculator. Sometimes our brains go, oops. So our common difference is negative 7. Let's write the formula. AN, we can find any term by taking the previous term and adding negative 7. That's our formula. Let's do letter B. Our common difference is going to be 12 minus 1, which is 11. All right, let's color code. Bidoop, bidoop. Bidoop, bidoop. So, our formula is we can find any term by taking the previous term plus 11. Letter C. To find our common difference, we do 12 minus 25. 12 minus 25 gives us negative 13. So, to find any term in this pattern, we take the previous term and we add negative 13 to it. Beautiful. Number 2, use the recursive formula to find the requested term. All right, so if A23 is 947, find A24. All right, to find the 24th term, we're going to use the 23rd term and add 17 to it. All right, well, A24 is 947 plus 17. So A24 is 964. I don't know why I was writing a 7. It's a 4. All right. Letter B. If the 15th term is negative 17, let's find the 16th term. Okay. Well, according to our formula, we can find any term, so the 16th term, by taking the previous term, the 15th, and subtracting 42. So to find A16, we're going to do negative 17 minus 42. So the 16th term is negative 59. All right. Number 3. If I know a sequence starts with 7, so starts with 7, common difference of 3, how many times should I add the common difference to 7 to find the 4th term? How about the 8th? How about the 12th? Okay, well, if we start with 7 and the common difference is 3, to get to the 2nd term, we add once. To the 3rd term, we add twice. To get to the 4th term, 3 times. So 3 times to get 4th term. All right. Well, to get to the 8th term, so that's 4, we add 3 again, 5, 6, 7, 8. Oh, that's 7 times. 7 times to get to 8th. How many do you think we need to add to get to the 12th term? You're right. 1 less than that. 11. And how about the 70th term? You got it. 1 less than that. And that leads us into the explicit formula for arithmetic. The explicit formula helps us because we don't need to use the previous term anymore. So let's check it out. The explicit formula, we can find any term by doing A1 first term plus D times n minus 1. So plus common difference times term number minus 1. And you'll see what I mean in a second. Let's try out the explicit formula for number 4. So really what we need is the first term and the common difference. So the first term is 9. That's easy. Let's find the common difference by doing 14 minus 9, which is 5. So AN equals our first term, 9, plus 5, n minus 1. Letter B, let's do the same thing. I have my first term at 7. Let's find the common difference. 11 minus 7 is 3. No, it's not. It's 4. My goodness, I just had a brain fart. Okay, so our formula, AN, any term, can be found by doing 7, our first term, plus 4 times n minus 1. And let's do letter C. Let's find the common difference here. 12 minus 25 is negative 11. So we can find any term by taking our first term, 25, plus negative 11 times n minus 1. Beautiful. Let's put that to use. I would like to find, I have a formula for you already done. Someone created it. That someone was me or whoever made the packet. I would like to find A22. Now this 22 is where this n goes. And it's the same as this n. So the 22nd term, A22, equals 573 plus 17 times 22 minus 1. This whole part goes into your calculator. The 22nd term is 930. Voila. Let's try letter B. Once again, I'm given the formula. I want to find the 12th term. So the n for an is 12, and the n for in the parentheses is also 12. So the 12th term is 324 minus 11 times 12 minus 1. A12 equals 203. Okay. Number 6. Greta must volunteer 225 hours for a community service project. She plans to volunteer for 6 hours each week. The sequence represents the number of volunteer hours she had left after 3 weeks have passed. First of all, is this arithmetic or geometric? Well, let's test it out. I always like to test for arithmetic first. So I'm going to do 219 minus 225. And that equals negative 6. All right. Is 219 minus 6 or plus negative 6 213? Yes, it's arithmetic. How many volunteer hours does Greta have left to fulfill her requirement after 5 weeks? Show your work. Okay. Well, after this is, she has 225. So this is 1 week, 2 week, 3 week. So we actually need to subtract twice more. So to get the 4th week, we do 207 minus 6. And to get the 5th week, we do 201 minus 6. And 201 minus 6 is 195. All right. Letter C. Which formula should you use to determine how many volunteer hours Greta has left after 30 weeks? I say explicit, because it's faster. Than writing 30, or a list of 30. Okay, let's calculate. Well, luckily for us, we have the explicit formula. All right, our n is 30. We want 30 weeks. Our common difference, or A1, our first is 225. That's our first term. And our common difference we already found was negative 6. Let's plug stuff in. All right, let's do it. A30 equals 225 plus negative 6 times 30 minus 1. All right, plug that into your calculator while I color code my life away. Beautiful. I get that A30 is 51. So she has 51 hours left after 30 weeks. Number 7. When first purchased, a tree sapling measures 15 centimeters. Every month thereafter, it grows 4 inches. All right, let's fill in the table. Month 1, that's N1. So month 1, it's 15 centimeters. Month 2, well, if it grows 4, that's adding 4. 19. Add 4 again. 23. And again. And again. So after 5 weeks, it looks like it's 31 centimeters. Now, letter B asks us to write the explicit or recursive formula. I always suggest to write the explicit, because it's easier to work with. So the explicit is an equals a1 plus dn minus 1. Recursive is an equals an minus 1 plus d. I think I'm going to use the explicit. An equals, our first term is 15, plus our common difference is 4, n minus 1. Letter C asks us, oh, you know what, let me write an example of this one, just in case you feel like it. It would look like this. And as simple and nice as it is, it doesn't really help us solve much, unless we continue the list. Letter C, however, asks us for 8 months. You could use the recursive formula to keep adding to see where it is at month 8. Or you can plug it into the explicit one we just found. So our n is 8. So A8 equals 15, which is our first term, plus 4, that's our common difference, 8 times 8 minus 1. All right, plug that into your calculator. You should get 43 centimeters. Beautiful. And that, my friends, is the unit. If you have any questions, please make sure to ask me or whoever your teacher is. Otherwise, have a wonderful rest of your day. Bye!